Ladies and gentlemen, this session is going to be on the role of innovative technologies in scaling up biogas. Please join me as I invite the panelists of this session onto the stage. Please put your hands together as we now invite onto the stage General Manager Armatec-FTS onto the stage, Mr. Ralf Schmid. Very warm welcome to you. May we also invite onto the stage co-founder and director JNF Biogas, Dr. Hans Friedmann, onto the stage, please. Very warm welcome to you. Please put your hands together as we now invite Chief Executive Officer, BioCover S.R.L, Mr. Ivan Roma. Very warm welcome to you. We also now invite onto the stage Head Gas Process and Pistons, Chicago Pneumatics, Mr. Sachin Sawant. Very warm welcome to you. We're also privileged to have with us CEO and co-founder BPC Instruments, Dr. Jing Lu, to kindly join us onto the stage. Very warm welcome to you. And ladies and gentlemen, may we now invite the moderator of the session, Arca Burnstech Private Limited, Mr. Srinivasan Kasula. Very warm welcome to you. Ladies and gentlemen, the session will highlight the crucial role of innovative technologies in scaling up biogas production. It is also going to let us know about the latest advancement in biogas setups and the cutting-edge purification technologies utilized to produce biomethane. Experts are going to discuss the potential impact of these innovations on biogas industry, exploring their effectiveness in increasing production efficiency, enhancing environmental sustainability, and expanding the market for renewable biomethane. With those words, may I request the moderator of this session to kindly take over. Thank you.
Thank you, ma'am. So, good evening, friends. And now we are going to take the session on role of innovative technologies and scaling up biogas. So, when it comes to the question of biogas, yes, the first most question which arises in my mind is let's break up this into the 4 different sections like feeding section, digestion section, the gas upgradation and utilization section, and the last is the organic manure treatment, whether it is solid or liquid manure section. So these are the ways where we split it differently. And today we have renowned experts from the field, and I'm very happy that right from the laboratory scale, we have large scale plant manufacturers as well as the developers. And when it comes to equipments, like the upgradation, the agitators, double membrane roof, the high pressure compressor, we have everything. So let's see, would like to understand most about from the experts rather than discussing or informing you about the technologies, that what is the difference or primary challenges you feel, Dr. Jing, that scaling from lab scale production or the lab scale models to the large scale or the actual models. So what differences you feel or the challenges are there?
Sorry for the interruption. We're also being joined by yet another speaker. Please put your hands together as we invite on stage Mr. Nek Singh Thakur, who is from the Biogas Engineering India Private Limited. Over to you, sir. Sorry for that interruption.
Yes. Welcome. Yes, Dr. Jing.
Okay.
So you can introduce yourself and you can start.
Okay, so good afternoon, everyone. So my name is Jing Liu. I'm from BPC Instrument, a Swedish company, innovative company. Well, the question is actually the challenge, transfer the lab technology or lab analysis to the full scale. Actually, I want to reform the question in a bit.
Sure.
In the way that I see the challenge is how to support the operation of a full-scale plant. And the lab analysis, a lab simulation, I would say analysis, is a tool. It's a powerful tool to support, to make sure the efficient operation of the full-scale plant. So, of course, there's a various consideration when you apply the technology. But what I want to say, the reason that we need to do more analysis, more monitoring, and because very simple, it's a biological process. It's not a simple tank. It's not a concrete or stainless steel, not stainless black iron tank. It's a living creature, just like a cow, just like ourselves. We need to take care of it. In order to take care of it, we need to consider how we actually analyze the feed, which is a feedstock. We need to analyze the process, make sure that we create the best environment for all these anaerobic bacteria. They are amazing. They can adapt to various feedstock in a way, but you have to take care of it. how to take care in the best way is you run, you gain experience, you do more analyze in the laboratory, and then you apply the knowledge, the technology to the full-scale operation. And that's the way to make sure that your full-scale operation can be optimized, so you get a much better energy throughput, the mass throughput. That's exactly what we need, because as an outcome, this will have a huge impact to the economic outcome for the plant.
Yes, no doubt, accuracy, precision, and as I said, that this is the tagline of your BPC instruments, and it fits perfectly. And when it comes to mixing or the agitation inside the digester, yes, there are various agitator suppliers. But today, Ralf is here, so I like to understand that what are the optimal mixing solutions, or how it differs in the large scale plants, or what we discuss about the small scale digesters, how it is different. So can you please add some lines on that, Ralf?
Yeah, thank you, Srinivas. Yeah, the mixing process is a very important thing. If you have decided what substrates you need, what dimension of the plant you have, and then it's important for the gas yield that you get a good mixing project too. Without mixing, homogenizing, you get not the gas yield you want to get. And therefore, yeah, and the second thing for the mixing process is that you reduce the viscosity in a small area around the propeller, and it also helps to get the bubbles on the surface where you get it then. And this and the second thing for the mixing process, what is very important, that first you have to destroy the layer for a swimming layer if you have light materials inside, and also to avoid that you get too much of sinking layer on the ground. And you can't completely avoid, but the process is better you mixed it permanently. And therefore, it's because we have sometimes also different substrates all over the year, differences. It's very good to have also reserves inside, so that you can steer it in that way you need it. And all the temperature outside is important, and different parameters, and therefore, yeah, you can steer it if you have reserved of power inside. And the normal way is to steer in intervals, and you can decide how long is the steering time and how long you make the brake time. And if some problems come with different substrates conditions, then you can make the steering times a little longer and the braking a bit shorter, and afterwards or in some weeks later you can change again. Therefore, it's very important yeah, to think about how to steer, and how many agitators you have to take inside, and in what position you want to take inside. And yeah, this is the main topics.
Yes, Ralf, you are absolutely correct. But when it comes to CSTR, yes, these points I totally agree to you. But since Dr. Hans is here, I would like to understand about whether you advise us about what is the difference between the CSTR, dry digestion and wet digestion, because this is the most important question. And the visitors who had visited our stalls, everybody was asking what is the difference, and whether we have to select dry digestion or wet digestion, and what are the advantages and disadvantages when it comes to the large scale plant.
Thank you for the introduction. My name is Hans Friedmann. I'm very long in that biogas business. And when I started with this biogas business, I was working with wet digestion. But why did we wet digestion? Because we had wet feedstocks. That was the reason. And about 20 years ago, in Germany, we had a new law which subsidized a little bit better the use of energy crops. But the energy crops was dry material. So we had to think about how to optimize our process for this dry material. The questions was, which amount of water would I like to use? Which amount of digestate would I like to handle and store? We must store the digestate very long time, so the capacity would be big. So we had to think about the process where we very safe this. And the process was we call it dry fermentation, but to be honest, dry fermentation is not so clever because if it's dry, no biology will work. So it's semi-dry. It's enough water for the bacteria to work. But it's in comparison to the classical wet digestion, a total another thing. The challenge there is to do this is how I handle this material which has high viscosity. We measure the high dry matter in the digester, and that's the core difference between wet and dry fermentation. It's the dry matter concentration in the digester. We are working between 15 and more than 20% in comparison to wet fermentation, 5 to 10% normally. And that causes drastically the mixing technology we have to use, the pumping technology, the sizing of the piping, and so on. So the difference is the viscosity in digester and to this related technology to handle the material.
Yes, so when we're talking about dry, wet, I'm sure that yes, you have rightly added some points on dry digestion, and Ralf has spoken about the wet digestion. But irrespective of the technology, Ivan is here who is representing BioCover, and we need BioCovers for any type of digesters. So I just wanted to ask Ivan that what are the innovations, because if you see the topic of our today's session is innovative technologies. So what is the innovation in the fabric which you bring to the table so that people will understand how your fabric is different from the existing balloon or double storage membrane suppliers in the market?
Thank you, Mr. Casula. With BioCover, we are really in touch with the producer about the PVC, and we are developing new coating formulation and also new chemical formulation. That is really important to increase the lifespan about the double membrane cover. Also, that is very important because when you have a different feeding system for your biogas plant or also different environmental condition, it's really important to find the correct chemical coating and also use that in the different way. That is one of the most point about the PVC choice. Also the feeding could be really important to the lifespan, because if you have a different feeding system is more dangerous or less dangerous for our PVC. That is really important, but we will see in the second question what is also the process of the manufacturing of the double membrane.
Well, there are some points which can be agreed upon, but yes, you have installed so many. When we spoke that you have mentioned you have installed close to 100 membranes on European biogas plants in last 1 year. That itself answers most of the questions.
Yeah, last year we are installing around 100 double membrane system in Italy, but also in France and in Germany. Our product is really customized in front of the environmental condition you have. So I think we have a great experience about the environmental condition you have in India, because it's really similar to Italy. So we have a high exposure at UV rays, but also we have the same sunlight insulation, and that is really important for us.
Okay. So yes, selecting all most of the products is a completely different story or different ball game. When it comes to upgradation units, I just want to understand, Mr. Neek Singh, that yes, you are giving the membrane systems, but most of the technology suppliers or the entrepreneurs, they want to understand that how they can select the cutting edge technologies and how your system differs from the existing systems.
Hello, everyone. Good afternoon. And first of all, thanks for including me in this session, especially considering there are 5 participants from the digester side and I'm from the purification. So that shows the confidence in our technology. So thank you. So both goes hands to hand, biogas purification and biogas generation. So Now, talking about the innovation, it's like the technology that we are using, which is membrane-based technology. It's already there. Innovation is the key of success. There is continuously improvement in that. But what is required? The sustainability in the Indian market. That's where we are really working. So what is happening if you see these machineries that are being used for the biogas purification, including using this membrane-based technology? These require very sophisticated machines, and they are very special compressor, which is oil-flooded screw compressors. So if you look, Biogas Engineering is the only company who has worked with three leading compressor manufacturers: the Wilter, which is USMIC, which is a group of immersion, Adicom, and the Bohr. So we are working with these companies to provide a sustainable solution for the Indian market. And that being said, they are very eagerly waiting for this opportunity to develop the product in India, just looking at the market growth in India. So it's really good to see for the sustainability, they are doing a lot. Same way goes with the membrane. And it's a two-way communication. We get the feedback from the customer, and that feedback we pass to our developer. And then they work on the solution. So like Evonik recently, they make the membrane which can handle more capacity in the same size. So that has helped in reduction of the overall footprint. So it's really good. So there are a lot of things from innovation point of that is also going on, but the sustainability also there we are working.
Yeah, I totally agree to you that Evonik is the market leaders, and I think I have read an article that Evonik has already completed 1,000 installations across the globe, which
Right.
tells the story itself. And we have seen the laboratory scale digesters, the digester equipment supplies like agitator, biogas membrane, upgradation unit. Now is the time for high pressure compressors. So Mr. Sachin Sawant is here from Chicago Pneumatics. So Mr. Sachin, I just wanted to understand about what are the different types of CNG or biogas compressors available right now in our country.
Yeah. Good afternoon, everyone. Good afternoon, ladies and gentlemen. And it's a good opportunity for us to talk about our product. I'm from Atlas Copco. It's a Swedish company. And Chicago Pneumatic is a brand which we represent in India. And we have manufacturing setup in India at Pune. There are two types of compressor primarily used for biogas compression. One is a screw compressor, which is used for the low pressure compression. And for the high pressure compression, the piston technology is used. There are three types of technology which is primarily available for biogas upgradation. First one is a PSA, the second one is a water scrubbing, and third one is a membrane technology. For the PSA technology, what you need is a compressor which can take the gas from the lower pressure at around 1.1 to 0.3 bar and compress it up to 250 bar. So when you compress it up to 250 bar, you can put it into the trailer, and the trailer can go to the fueling station, and then further it does the dispensing and other thing. The second technology, which is water scrubbing, which requires a pressure of around 7 to 8 bar. So you require a compressor of around 10 bar discharge, and it takes the suction of 0.1 and 3 bar. So you need a medium pressure compressor which can compress the gas up to 10 bar. That is before the purification, and which can handle methane as well as the CO2. And then it can compress, after the purification, it goes to the high pressure compressor. So from there, 7 to 250 bar, it does with the high pressure compressor. The third technology, which is membrane technology, which require a 14 bar compressor, and which also require a compressor which can handle CO2 as well as methane. And the methane gets separated in the membrane, and then what you get at the outlet is a methane, which requires to be compressed from 14 bar to 250 bar. So these are the three types of technology which are available. What is important that we select the right technology for a right application, because before the purification, we need to have the oil-free air technology so that it could not damage the other component which are there in the purification unit. So I think we as Atlas Copco, we provide a solution not only for the compressor, also provide the solution for the expert advice on the selection of the compressor.
Okay, so yes, I have seen the different models you are offering on the table, and again I would like to come to Dr. Jeng about Dr. Jing, when it comes to process monitoring and control, no doubt that your BMP equipment is out of the world and your residual gas potential can be tested, BMP can be tested. But most of the people today or yesterday visiting the stalls, they asked me only question that how does the process monitoring and control have, or what is the difference, or how you can control in terms of having higher biogas yields?
Well, this is actually a quite big question, I would say. I would say process monitoring control is a one tool to optimize the production. But actually, we have to look at when we talk about the process monitoring and control, it has to also look like a little bit of broader aspect, not only looking at the full-scale plant, but you have to control your feedstock. You have to control the quality, select the right feedstock, and maybe you have to do something like a treatment or something, cold digestion, whatever it is. This all is a part of the monitoring, optimization part of it. Of course, when you have the best feedstock, or not the best feedstock, if you know your feedstock, if you choose the right feedstock, and then you know that's a few, but that means that it will convert to methane. So you have the potential, but it doesn't mean in the reality you will have, you will achieve that. Then it comes out to process optimization. You need the right process configuration, and you need the right operational procedure. Many cases, because it's a fermentation process. Once again, I mentioned this is a living biogas plant. It's a kind of living creature. You have to follow. It's a dynamic. They're not just, oh, I build a plant with this capacity. It's the fixed value. It's not. It's a dynamic. It's very much depending on who operates, the operating history, how much knowledge you have. In order to know, to optimize, to maximize the energy, and also make sure the best economic outcome, you need to close monitoring. It's just like driving a car. You have the best car, you have the best fuel. If you don't have the right skill or right driver, you don't drive the car standing there. So the same thing for process monitoring control. This is a tool allow people to operate. But one more thing I just said, this is a technology. Technology need to go through, implement by people. I think it's a critical important that we need to have a right engineer, process engineer, technician to implement those technology. You can have a best tool, but if you don't know how to use that, you're still not able to implement. I don't know if I answered the question, but I think
yes, sure. I totally agree to you when it comes to process optimization or process engineering point of view. But at lab scale, it's okay. But let's hear from Ralf. Ralf, can you show some examples or successful projects or running projects where your mixing optimization has helped in biogas increment?
Yes, I can do. I don't say that we are also for 25 years on the market in Germany, and the biogas technology started 20 years before here in India. Therefore, I have no examples here in the Indian market, because here the biogas technology is on a ramp-up starting phase. And but I have the experience in Germany, and we manufactured over 3,000 agitators in that time, and we learned to optimize them and get new technique inside. And the combination with new technique of the agitating, and also some handle and good handling with the substrate, we get simple and not simple, many examples for increasing of gas yield over 20% till at the beginning. Here in the Indian market, we start with new technology and take our experience inside, and this is a very good thing. To learn from the experience from the history.
Okay, Ralf, when it comes to technology, yes, I totally agree that your agitators are quite capable to operate or treat up to 15% of the total solids. But when it comes to dry digestion, I would like to understand from Hans that what are the challenges or primary challenges when it comes to CSTR-based dry digestion you have seen, and how the innovations have helped to address these challenges?
Yeah, thank you. To be honest, the biggest challenge is to convince people that this new technology will work and will work good on the market. So to realize the innovation, you only need good engineering work. That can be handled. Um, but with this semi-dry fermentation we have some effects which helps us to come into the market and convincing people from the technology. Look, if you make the dry fermentation, the digester sizes is reduced drastically, up to 50%. So I need less volume, less footprint, less concrete to construct the digester, and of course, in following this, less capex. That's the first step. The second step is, let's discuss about mixing. Mixing is a question of energy dissipation density in the digester. Just an engineering word. But this means in watt per cubic meter, if the digester has doubled the size, you need double the energy for a feasible mixing. So reducing the digester size by optimizing the process, handling this higher viscous material, you reduce the energy costs for mixing. That's an important point for the operation costs. You reduce the amount of liquid you need, so less liquid to store, less liquid to handle, and this both affects the OPEX. So you have two, for the owner and the operator, very important points. That's CAPEX and OPEX, optimizing and fixed to the feedstock in a very positive way. And that's the way to convince people to do the dry fermentation.
Yes, I totally agree to you when it comes to the technical part of it, but the economics plays also a very important. So we need to understand the capex and opex versus the CSTR ways, wet digestion. So my next question would be for Ivan. So Ivan, are there any proven fabrics or proven case studies for fabrics which have made a huge difference in double membrane storage, which can differ from the existing fabrics?
Of course, the main goal is reduce the gas losses. That is our focus because you know, if you reduce the permeability of the PVC, you can save more gas. But in the same time, you can also save the cover because PVC cover is made with different layer, and inside this one are coated a net that give strong to the PVC. If the gas go inside that PVC, reduce the lifetime a lot about the cover. With our cover, we can reduce the permeability, and in the same time, we can save life. Avoid the faster replacement about the cover is our target. In this way, also, we can have a more cover, more durability, and also we can improve the lifespan about the project.
Yes, innovations always help, which we had already discussed. But when it comes to innovations, Mr. Nick, I would like to understand that innovations at lab scale or at the ground level is different. And when it comes to installing the large scale plants, what are the primary challenges you faced while installation of the projects, and how to overcome these? Because most of the technology or the entrepreneurs who are getting into biogas, they would like to understand the difference between, how to overcome the innovative challenges which nobody has experienced so far.
See, scale of the biogas industry, it's not a big issue, scale up. The reason being, I mean, you are also in this industry and you know that maximum plant, more than, let's say about 80% of the plant would be about a 10-ton capacity. There will be hardly which will go up to 15 or 20 tons. So that's the one thing. But the issue that really comes, it's the startup. It's during the startup, as Mr. Lute rightly said, it is the process engineering and automation that comes into the picture right now. Let's say someone is setting up a plan of 10 ton, but what happens when they start the plant, they will hardly have the gas equivalent to 300 or 400. Then to still achieve that purity level and the yield level, it's very difficult if you continue to operate the way it is designed. So that's where the automation and the, this SCADA system which we provide, it has a lot of automation where it automatically see the variation and that, looking at those variation, it varies the operating parameter and still get the yield and purity. But for that, there's one thing which happens, which is like with the automation, the cost also increases. That's the one thing, but at the same time, there are ways to optimize that. So we are working hard on that thing also, how to optimize so that client can have a peace of mind throughout the operation, entire operation of their, of the plant.
Yes, you're very rightly you have said that, and our chairman of Indian Biogas Association, he always say that biogas is a baby, and collectively we all have to take care of that baby. And at the right time, if you give it to the commissioning, yes, it will be stabilized. So I would like to ask Sachin Sawant that when it comes to high pressure compressors, yet there are many established players in the market. So what are the technological advances your compressor has over the other products in the market?
Yeah, it's a good question. I think there are a lot of compressor manufacturers which are there in the market. But one important thing which is there in the compressor is that your compressor should be having a zero methane loss, which means during the compression, the gas leaks through the seal. And if you are not capturing it and again recirculating it back to the suction, then you are practically venting the gas. So you are already spending the energy to produce the gas. And during the compression, if the gas is leaking, then practically you are not only wasting the energy during the compression, you are also wasting the gas. And third effect is the methane emission, which is harmful to the environment. So your compressors need to be designed to avoid the methane emission. Second important thing is typically the compressors are designed for the fixed suction pressure. If you see it in the industry, it is taking a feed from the pipeline, but biogas industry is typically different industry. It requires a compressor which can have a turn down option. So compressor should at least come to 30% level of turn down, because biogas production is not continuous like a pipeline. So you always get high. Sometimes the pressure increases. Sometimes the pressure goes low. If you use the fixed speed machine for biogas compression, then there is a possibility of tripping of the compressor due to the low suction. So your compressor should modulate their RPM, and it should take the feed from the available sources, and it should deliver the available gas to the trailer or to the grid. So you need to have the VFD control for the modulation. So that's the important technology which you should look for. And the third and most important thing is the service intervals, because the biogas also requires continuous operation. So you require a longest service interval. So your component should be designed in such a way that it should also handle the impurities. Also, it should give the longer life of the internal components. So the service intervals are also important in this sector. And the last one, the cost of the compression. I think the cost of the compression is related with the energy. So the lesser the cost of the compression, I think your entire load on the biogas plant would be reduced.
Yes, no doubt periodical checks and preventive annual maintenance is what it is required. So, Dr. Jing, okay, the innovations on the ground level we are talking about, but when it comes to innovations at the laboratory scale reactors, we have already seen and we are thrilled every year you come up with a new product. So, what is the new innovation you are going to bring to, after AMPTS BMP3 or, part 3? So would you like to discuss or explain us about the new innovations you are going to work on the same?
Interesting question. One thing is, of course, innovation is not only technology. Innovation is also not only allowed expert to make this work, but also the average engineer or anyone else. So how to make it work in order to allow the industry, not the doctor, for instance, technician can operate equally as good as expert. And that's a huge challenge, to be honest. We can develop the very good technology, but we have to make sure that the technology can be easily operated by anyone. That's a huge challenge. That's the difference between the so-called R&D, technology development, and compared to you have already a product that allow industry to utilize. And we have in this journey for over 18 years or 20 years, and we, because our original background comes from a scientific, academic side, and become an entrepreneur. So I know the gap, and I know so important. In order to boost our biomethane production, biogas production, not only we need to have right people, education, and experience. I mean, that's no doubt, because somebody, we need a man, but also a right tool. So I would say we focus a lot of new technology development, but also our innovation come into how we can make the tool not only so powerful or functional feature, but easy to operate. And make sure that lower the barrier to allow everyone to run it. So, and that's one aspect. Another aspect is the one we talk about. Yeah, you mentioned automation and also the monitor and the control. And the process optimization still require at the end the automation to implement. So there's a link, but they are different. And also when you operate a plant, you have to look at feedstock as the first steps. And then the next step is to look at the process. And of course, if you go even earlier, the feasibility study, you need to even consider what feedstock you're dealing with. All this chain. And then, of course, if we look at the whole biogas chain, now I'm working on the raw biogas production. Now later on we have this pump and upgrading and all these things. There are a lot of things need to be. But focus on my field, we're working on to solve the so-called the low-hanging fruit, which means that with a limited effort for everyone, you can give a big changes. And then once you are there are still a lot of potential for further improvement. At the end, the goal is to make sure the plant is operate full capacity in the how to say, to maximize the output, energy output, to have a best return of investment.
Yes, I personally love about the energy or the laboratory reactors and the way they operate. But when it comes to energy, yes, I would like to ask Ralph about what are the energy efficient agitators you bring to the table, or how it is different from the existing players?
Yes, there have something changed since the beginning. The few last years we learned that it's a very successful experience to change from high-speed agitators go to low-speed agitators. High speed means about 400 or more than 200 till 400 RPMs, and low speed are about 100 RPMs. And this leads to much more less energy consumption of the motors. In the former times, we need for a steering process motors between 18 kilowatts, 22 kilowatts till 30 kilowatt, and meanwhile we get the better solutions with 7.5 kilowatt. And in the same way, the propellers getting greater, and they get more force and also more fluid volume can handle, and this is a very good way to save the energy and yeah, serve a high efficiency till the last solutions.
Okay, so I would like to
yeah, and some topics, if you change the propeller in a very good way, in a dry-dimensional propeller, he have the optimum of the steering moments because there are less turbulences. Then you have a metal sheet, metal propeller with metal plates, and you have with the low speed not the abrasion. So the system are much more stable and more efficiency and need not that energy like in former time.
Yeah, when it comes to CSTR based liquid digesters or up to 10% solids, it's quite easy. But I would like to understand from Dr. Hans that are there any considerations while selecting the feedstock when we talk about dry digestion, or you can the dry digestion can work across any type of raw material, or is there any consideration or facts we need to consider?
I didn't understand, sorry.
are there any considerations of the feedstocks which we need to look into when it comes to dry digestion, or dry digestion can work across all the feedstocks?
Of course not. But let me say, mixing of 10% is also not easy, not simple. You need clever mixer, high efficient mixer to reduce the energy costs for mixing. Dry digestion gives no sense for a liquid feedstock for sure. Cow manure with 8 or 10% dry matter is not possible to use in a dry digester. So it's done for dry feedstock, like silage, press mud, straw, the new and the modern feedstocks for biogas plants. Energy crops, from my point of view, energy crops will be the core source for energy, for bioenergy in future, because that's the big amount we have. It's not waste we have the big amount. It's the energy crops growing on the field each year. And for this feedstock, dry digestion is designed, constructed. If I think in what are we doing here is we fight against global warming. That's our mission, all of us here. And from my point of view, in Germany we all talk about hydrogen, battery electric, photovoltaics and so on. I'm sure this will not save our planet. This will help us to do. But without agriculture and biogas in combination, with the circular economy we can do with this. With this, we can really save the planet. If I use energy crops in a biogas plant and I operate the land in a clever way, I can fix carbon in the soil. In my own plant, I'm using Sylvia, a new plant, as energy crop. This plant, operated well, will buffer 5 tons of CO2 each year per hectare. And we harvest the energy, and if I make a whole CO2 balance for the whole lifetime, each year, we have a negative CO2 balance if we use our biogas in the fuel market, for example. So we need such technologies to handle such feedstocks in a proper way and efficient and cost efficient especially.
Yeah, no doubt feedstock securing is a key part, and the projects or the companies who have secured feedstock for 365 days is nothing like that what every entrepreneur is looking for. And I still remember the first plant which we are working, I think in 2010 when Shuklaji is here. So I used to discuss with him, and we also met about before installation of the first project in India in 2010. There were no double membrane roofs available in the country, as well as we wanted to import from Germany because Germany being the leader in double membrane roofs or biogas equipments. But the major question our entrepreneur used to ask us about whether these membranes sustain in the weather conditions or the exposures India has, which even the Germans couldn't answer during those days. But now, yes, since you are here and you are replacing so many European membranes, can you throw some light on exposure and the weather conditions, or how it different from other countries and India?
Yeah, of course. Our experience is also based on the replacement cover that in the past, in the last 5 or 6 years, we replace a lot of old cover, and we see what's happened during that time. The main focus are in 3 points. In BioCover, the most important thing is the design. The projection time is really important. The perfect shape, the perfect division about the force that are in the membrane, especially in the outer and in the inner membrane, is really important. Also in BioCover, the second point, we are really specialized in the processing manufacturing. So in that way, we have some special product to increase the lifespan, like a special processing for the center of the inner membrane. It's called Bio-methane. It's a multi-layer stratus about PVC, and that increases a lot the life of the inner membrane. Another point is our special welding, because we weld only with high frequency welding machine. All our welding machine is 4.0. That is really important because we can recording every single weld is done in our membrane. That is important because the power of the welding is the focus. If you weld without the correct power, you can't have a safe product. In that case, all welding machine can help us checking every single power weld. That is really important. Another thing is the size of the welding. We normally weld at 65 millimeter wide, and it's really important for the correct distribution about the force above the membrane. The other system we use is increase the wide of this welding and weld the outside face of the membrane and the inside face. That is important because in outside you have the UV radius that ruin a little bit the welding, but the welding inside the membrane is protected from the UV radio. In this way, we can weld around 12 centimeter wide welding. That is really important. Another thing for the inner membrane is dissolving the PVC, dissolving the border of the welding. In this way, we can't see the gas go inside the inner membrane. That is really important for the lifespan about the membrane. First, and the last point, for increase the lifetime is really important the installation. Have a perfect installation could change the life about the cover. That is our specific point because we have 5 fitter team able to go installation around the world without any problem. So in Asia, we also have some installation like in Java Island, like in South Korea. So we are able to go worldwide with our product.
Ivan, this is something new to us because in India, everybody talks about the fabric thickness. So they only compare about the fabric thickness and they are happy. But the welding joints and the electrical efficiency or the electrical, the temperature at you're welding, this is completely new. But let's see, when it comes to upgradation units, I would like to understand the same points. That what are the trends you foresee in the upgradation units or the technology when it comes to membrane separation?
See, modularization, standardization, that is going to happen. I'll give you the example. You know, what happened when you are developing a project, there are a lot of engineering thoughts goes behind it. And if you are doing that customized engineering for every project, that's something which increases the cost. The Indian market is very cost sensitive, and the kind of feedstock and the quantity that is available at one location, we have seen there are standard size, standard capacity projects are coming like 5 ton, 10 ton, 15 ton, like that. So ultimately that modularization and this, when I say modularization, it is two-way. One, people are putting large capacity plant upfront, planning for the future. So what they do, like I give you an example, we are working on a project where they were thinking about a 20-ton plant, but currently for initial 2 year, it will be only 9 or 10-ton capacity. But we designed the plant for 20 ton, which would cost less compared to 2 10-ton plant. And we gave the provision for the adding additional modules. So it will be like simply plug and play. You just install new membrane, and in days time only you will enhance the capacity. So standardize, skids, modularize, and taking jobs off the site. That's the thing which we see. And the one more thing that I see now, looking at the market in India, which is emerging like anything, all the compressor players or all the vendors, they are doing, local manufacturing. They are becoming local. And in coming years, we will see most of the vendors, they will start local fabrication, and that will also optimize the cost.
Dr. Jing, would you like to add some points about how your technology or the equipments help in the entrepreneurs for scaling or the efficiency or the increasing the biogas production at the field level?
Yeah, actually, I briefly mentioned that in my previous talk. I would say, number one, look at your feedstock. Make sure you have a stable supply. Feedstock will be changing. They changed over the year, both on quantity and quality. But even the feasibility study, we have to look at feedstock, make sure the right process configuration like for instance, dry fermentation, wet fermentation, the feedstock are actually connect to the type of process configuration. And then working on the feedstock, have good control, quality control, optimize your feedstock, because that's the fundamental and requirement for operating a full scale. Once you have that, you can further on working on the process optimization, try to convert as much as possible your potential, energy potential from your feedstock to biomethane. And then that's basically, there's still a lot of things to do. Then you need the tool. The professional operation will need the professional tool to do that. And then, of course, the right person, I would say. Yeah.
No doubt the feedstock securing and working on the feedstock is a right way we looked at. And Sachin, I just wanted to understand about what are the environmental factors like temperature, because personally I installed one compressor in southern part of the India, you can say near Maharashtra, which worked beautifully. But the same compressor when I installed in the northern part of the country in one location at Punjab, it was not working. So what are the challenges where temperature, humidity, if you have any changes, how to optimize or how to overcome those challenges?
Yeah, it's a very good question. I think the compressor also should be designed considering the tropicalized condition. Usually on the southern part or the west part, you have a high temperature. So your outlet temperature also goes high. So when you're feeding the gas into the trailer, your less volume gets filled. But then to overcome that, what you need to have is a better cooling mechanism. Your cooler should be rightly sized for that particular compressor. As well as if you go to the northern part, if the moisture is not removed from the gas, then you will find the hydrates also forming in the lines, and which also chokes the line. So practically you should also have the VFD mechanism for the cooling system, where it can modulate based on the temperature of the compressor. So that's the kind of technological advancement what you can look for.
So basically, you mean to say that latitude and longitude plays a key role when it comes to selection of upgradation as well as your high pressure compressors.
That's what.
So, Ralph, I would like to ask you about, yes, when it comes to innovations and technology advancements, everything is okay. But again, do these factors have some impact on the operational expenses or the maintenance of the cost, or it's almost the same?
Yeah, maintenance has most part of the costs if you have to do it. And the best maintenance is you have not to do something. And this is the changing also the last decades to get a technique who are much more standable and run as long as possible. Only if they are very unexpected occurs, exceptional circumstances, nothing should be happened within a very long time. I mean, the first 5 years you should not do anything at maintenance. You have to control and to check some parameters. You have to control the energy consumption and the vibration or noises, or also the temperature. But normally we want to avoid unplanned maintenance. If we do maintenance, then it should be planned and in a long term. This means that wear parts should also hold for 5 years and or later, and we need also some limits, intervention limits, so that we see now we have something to do and we can plan it. We have to scratch unplanned maintenance and should take planned maintenance, and then we are prepared. And it had to be possible. It must be possible every agitators to repair within some hours on site. And if it is possible designed, you have modular modules inside, so it could be very quick disassembled and also repaired or exchanged if necessary. But the first years, nothing should happen if the plant works in a normal way.
Okay, so it's a good news for the entrepreneurs or the project owners that innovations doesn't cost you extra maintenance or operations. So it's a well taken point. But Hans, I would like to understand that what are the control parameters help in optimizing the digestion technologies when it comes to dry digestion or CSTR based dry digestion?
Yeah, uh, I think the control systems for biogas plants changed drastically in the last 30 years. When I started, we had two fields. The one was the more agricultural type of biogas plant, mostly operated by hand by the farmer. Very simple technology. The reason was the cost must be low. The capex must be very low because the profitability, the plants were quite low. I was starting in the 80s last century with more industrialized biogas plants. There we had the control system because the staff was not there to handle. It was too expensive to do. In the meantime, even in the agricultural sector, the plants become big and very big, very modern. In the meantime, you have no chance to operate a biogas plant in a good way without a good process control system, with a good monitoring of the plant. And you need this monitoring even for the feedstock input, for the gas output, to get your numbers, to control the profitability, and also for the process itself. You should do this in a way which is necessary, not over control, because over control often leads to become nervous about the process. Because the biogas process is a quite slow process, so you must not measure the data each 10 seconds. Sometimes twice a week is enough. But you must have, from the control system to operate the plant, imagine you have so many valves, pumps, sensors. You never will be able to do this without a very good control system, and our dry fermentation system wouldn't work without.
Yeah, no doubt. Control system has to be monitored, and when it comes to longevity, we need to take a different call. But when it comes to maintenance and longevity of the fabric, Ivan, what would you like to add? Or are these double membrane roofs no maintenance or no worries required?
It's a great question. So the environmental condition change a lot of things. So that is very important to show us the correct quality of the coating. That is the most of thing. But also it's really important doing the better welding and the better design. Environmental, and also I told you the feeding system is really important for that. I think the best quality PVC with multi-layer is really important, also in the high temperatures or also in high light UV exposure. That is really important. But the most important thing, I think, is the welding. Welding must do the better shoot.
Okay. So, and Nick, I would like to understand about when it comes to upgradation units. Yes, you are also providing membrane systems. How different your systems are compared to the other products in the market, and how it has the financial impact, or you can say the capex wise impact compared to your competitors?
So, in terms of how it is different, I would say it is the latest and greatest technology available out in the market right now. It, with membrane system, you get peace of mind. It is not sensitive to any change in composition. You give the variation of the composition, because when you are digesting some material, you can't guarantee one particular number. There will be variation. So you define those variation on upfront. That's very good in that. There will be variation in the flow to the from the digester system just because of the temperature, feedstock quality, and season wise. So that variation should also be able to accommodate the system. So membrane technology, or I would say membrane in itself, it's a well-proven product. It's the engineering that is more important, what we are feeding to membrane to avoid all the contaminants that can damage to the membrane. That engineering skill is important. So once that is done, this is the technology which gives you the peace of mind, runs for years without any trouble, continuously 24/7, highly automatic. In terms of the capex, I always say that you look at the life cycle of the project. It's not like initial investment. What you are achieving over a years overall, that's the important. So capex wise, I don't have base number of other technologies, so I can't really say, but I would say it's comparable. In fact, it would be better compared to the life cycle of the project.
Okay, so you mean to say it is a plug-in and forget it types of technology where it works on its own, irrespective of whatever gas quality after the pre-processing is there.
I will just add one thing. Our plants in US, they are operating without the operator. It's like only general inspection and everything is highly automatic. So they just get the messages if there is some trouble.
Perfect, perfect.
So
this
it's
is what
that kind of automation.
yes,
And
this is
same we are following.
this is
here.
what even the Indian plants are looking for. That you have to reduce the manpower, you have to reduce the efficiency, increase the efficiency, and reduce the manpower. Yes.
And that's
So-
what we have.
Yeah, Mr. Sachin, I just wanted to understand about when it comes to compressor selection. You also help the entrepreneurs to selecting the compressors based on the gas sale part of it, like whether they want to add the gas in the gas grade or compress it to 200 bars or 250 bars, or whether it is first stage compressor or second stage compressors, and how different you are from the other competitors.
Yeah. See, as far as selection of the compressor, it is purely related with the type of gas what you are getting. That's the first primary thing what you need to see. Again, the sulfur content. In addition to that, the kind of pressure the customer is trying to look for. If they are looking for the 250 bar compression for the trailer filling application, then different technology is used. If it is taking a suction from the lower pressure, then the 5-stage technology is used. If it is from the medium pressure, then it is a 3-stage technology which is used. For the grid injection, yes, there is a different technology which is available, which can take the gas pressure up to 42 bar, and maximum it can also take up to the 60 bar level. So the selection is purely based on the plant need. What is important in the selection, you don't have to over select the machine, you don't have to under select. What you need to see during the selection, it covers the entire range of the generation. And also there are compressors now what we have designed, it has a module. So today your requirement is on the lower side, you use the one module, and then later on you can upgrade the same compressor with the addition of few modules. So that's going to be the future now.
Okay, perfect. So I think including the gas in the gas grid is not a problem anymore, which was a problem, a few years back. We used to struggle. We used to struggle with various pressure reducing valves, and particularly when it comes to technology, I think we can discuss the whole day. And since time is a constraint, and we are fortunate to have Gauravji here, so can we have him on stage? Yes, yes.
Okay. Thank you so much. I'm Gaurav Mishra, and I'm thankful to IBA for inviting me for this session. Although I have gate crashed into the technology session, I was supposed to come in the policy and the finance, which was supposed to be in the second session earlier. But I was going through and I was actually listening what the discussions were going on, and I'm happy to see the amazing audience and the kind of interest they have shown in the biogas technology as such, and the learned people, the the people who are sitting over here, and they have been putting their best knowledge in the forefront. I'm Gaurav Mishra. I'm representing Ministry of New and Renewable Energy. And as it was mentioned earlier during the discussion that biogas is a baby. Yes, I really appreciate that part. And all of us are taking care of a baby. And from the ministry, I think I should say we are providing the best possible and the correct way of nourishment to this baby so that it can grow to the national level.
Yes. Gaurav sir, I just have a small question that
Yeah.
I have been knowing you since when you were in Gujarat long time. And now since you're the right person to head this MNRE section, I would like to understand that what is your vision in the sector or the future of this sector?
Correct. Thank you. So I'm sure, like most of the people sitting over here, they have gone through our the policies, the National Bioenergy Program, which my the team who are already sitting. One of my colleague, Mr. Meena, is already here, and our secretary and the joint secretary, they have a vision actually towards. And not only them, the government has a very clear vision about the biogas as such. And not only the biogas, there is a complete program we are leading here at the national level, which is called as a National Bioenergy Program. I'm sure if you wanted to go through more in deep on that program, you can touch base with the website. You can have a complete picture. So just to give you the vision on how we wanted to take it forward, I'll take you a little like 10 months back from right now. So the ministry understood the importance of bioenergy and which the thought process with to bring it to the national level and to bring the biomass energy at the mainstream level. So they initiated this national bioenergy program and launched it in the November 2022. So which has got three main different components, which is like it has actually divided in two different phases. The first phase, out of which like total outlay was for the both phases is somewhere around 1700 crores we are talking about. And that too till 2025-26 we will be like providing a financial support on those lines. So first phase is already going on. And under this first phase, we are having three main divisions. Like one is biogas, wherein the team is focusing only on the small and medium scale biogas plants. Then we have a biomass power division and all. So wherein we are not only focusing on how the biomass can be used for different application for the power as well. We are also looking forward, if suppose if we have to address the paddy stubble burning issues and all, how it can be converted to like the pellets or the briquettes, and how it can be used for the different application, be it for the thermal side or for the power generation sides. That are kind of efforts we have created, and we have created the guidelines for utilization of that part. And then a very important part is the biogas side, what we are talking about, which falls under the waste to energy segment. So under that segment, not only from the different the distillery spent wash based biogas generation part, also from the different substrates, we are actually using it for the bio CBG. And to the surprise, and I'm happy to mention over here, in last 10 months, we have actually supported, there are the different slabs we have provided. Like I'm sure if you can go through the website, you'll see how much the central financial assistance we are providing. Around 50 such odd projects we have, so far we have supported financially from the ministry side. And we are still going ahead. And then the next phase also, we have already started taking the applications. And once the format is like it initially comes to, there is a BioUrja portal. So any stakeholders, we are trying to make the policies and the process in such like easy way, so that they can simply submit the applications on that portal. It goes to the AREDA for monitoring of or the evaluation of all the documents. Then it comes to us. So that's how like we are pitching for the biogas sector as such. And we really looking forward. And not only for this, we have started preparing a kind of a roadmap for the bioenergy for the next 7 to 10 years. So that is immediate terms. And for 2030, 2050 and 2070, that is for the considering the decarbonization plans and everything. So yes, ministry is geared up for that.
Yes, no doubt we are talking about the technology, but yes, without your support or without ministry support, we are nowhere. And we have been witnessing this right from Shuklaji's time. And yes, right now you are there. So we feel that the bioenergy section is in the safe hands. And yes, I would like my audience to ask any questions are there, because time is a constraint, so we can utilize.
Good evening, sir. Thank you for coming here.
Such a pleasure.
One question is there. The Reliance and Adani company is there, and they were saying that the feedstock problem and subsidy is not up to the mark provided by the government. So there was some question on the expansion and this plan.
Right. I do understand your concerns, because some of the projects we are also seeing there is issues related to the offtake also. but trust me, the government, from the ministry point of view, if I say, we are actually evaluating on a very in-depth level, and we are trying to come up with the maximum possible support to address these issues, and at the different forums we are reaching out, because some of the activities are addressed by the different ministries. So we are actually touching base with them so that it can be addressed timely, and so that this sector as such can flourish in that way.
Second question is that some support is also favored from the government of India and state government about the spend wash. The pollutions also bother some foundation about the spend wash handle, about when the biogas is formed from the spend wash, and again handle to consume spend wash after losing the energy. It is the very challenging, and such like that per estimate after made the biogas, and the sustainability of the waste again recycled from this.
Correct. So I think the team here, who are the best people to address this, the technical part of this. So I think they would be,
So when it
I
comes
will be
to-
happy if they answer on this.
Yeah, when it comes to technology, we can discuss it on one-to-one basis. But subsidy, at least sir has answered in a very passionate and patient, having a patience way. But sir, frankly, whoever comes to me asking or saying that, what is the subsidy, or, if there is subsidy, I will install the plant. Straight away I say that if you are installing the plant for the subsidy, then don't install the plant, because these projects have to be viable and feasible on its own. So forget about the subsidy, because subsidy is just the push to the field, and already MNRE has pushed it to a level that now Reliance and big sharks are entering into the market. So you don't need any subsidy support, to be very frank. And yes, technology, as I said, that we can discuss one-to-one basis, because we the next session would be, they are getting ready for the next session.
Thank
So
you,
if
sir.
there
Thank
are
you.
any other questions? Yes.
Central financial assistance is only for the MSW or waste to energy plants. If it was extended to some bioenergy crops converting into the CBG, then it was helpful. It was clearly mentioned that central financial assistance for the CBG plants is only to the waste to energy plants, not for the bioenergy crops. If we include the bioenergy crops, then it will again boost the industry.
We'll keep a note of this.
Thank you.
Yeah.
Basically, if you see the subsidy, central financial assistance, not only on the overall project, but it's also claims that, it is for 4,800 kgs of bio-CNG,
Correct.
irrespective of the feedstocks.
Sir, not sir. It was clearly mentioned that in the waste to energy crops, it was clearly mentioned that either municipal solid waste or the biomass which is generated from the crop residue. I am telling that if there is any crop specially grown for the any bioenergy crops for the green hydrogen or the CBG, then the financial assistance is not there to that. If it was included, then it again boosts the industry. Thank you.
Yeah, sir is there, so.
Okay, we'll keep we have taken a note of this. We'll address it. Sure. Thank you.
So any more questions, or we can wrap the session so that, the next session would be ready. Yeah, I think one last question we'll take. And
Hello, I am Dr. Tushar Bhaumik from MBS Engineering. I have just one query to Mr. Gaurav. What is the future of bio-LNG in India, and how soon it will come, or it will be delayed?
You asking me?
Yeah.
Okay. I think you're asking for something which is in future, but I think I see this is here already. We are into that phase wherein we have started taking the bioenergy on a different platform now. So I'm sure not only from the ministry point of view, it actually needs the continuous and the back-to-back support from the stakeholders as well. So once there is a collective efforts, I'm sure like everyone can, whatever we dream of bringing the main bioenergy in the mainstream, we can do that.
so I would like to add that, when you talk about the future or the, for biogas sector, Ivan is here. So from past 3 years, he has been telling me only the single statement that whatever Italian biogas industry has seen 10 years back, he now senses that Indian biogas energy is ready to boom. So we are only 30, 40 projects, and he, according to him, 1,000 projects in span of 5 years is not a big deal for India. Again, when you talk about Germany, yes, the entire Europe has witnessed, more than 9,000 to 14,000 plants within a span of 3-4 years, 20 years back. So this is the time, or I can say that this is just the beginning rather than future. This is the beginning, and we have a huge potential for such plants across the country.
That's true. It's basically for transportations of more molecules of methane. Bio-LNG can be a very nice alternative. Thank you.
Sure.
Thank you.
Thank you. Thank you, everyone.
Thank you so much, distinguished panelists, for that wonderful session. Thank you so much, moderator of the session, for wonderfully conducting and concluding the session. Ladies and gentlemen, on behalf of Informa Market and IBA, we would like to present mementos to our panelists on the stage. We would like to present a memento to, may I request the moderator of the session to do the honors, and please present a memento to Shri Gaurav Mishra from MNRE. Thank you so much, sir, for being with us. And may we also now request the moderator of the session to kindly present a memento to Mr. Ralf Schmid. Kindly put your hands together and bring in a little more energy. We are talking about energy here. We would like to present a memento to Mr. Ivan Roma. Thank you so much for participating and enriching all of us. Presenting a memento to Mr. Ivan Roma. May we now present a memento to Mr. Sachin Sawant. Thank you so much. Presenting a memento to Mr. Sachin Sawant. We now present a memento to Dr. Jing Lu. We present a memento to Dr. Jing Lu. Thank you so much. We also extend a heartfelt gratitude to Mr. Nick Singh. Thank you so much, sir, for joining us. Presenting a token of love and appreciation to Mr. Nek Singh Thakur. Thank you so much, sir. Ladies and gentlemen, kindly put your hands together. A huge round of applause for the moderator of the session for conducting and concluding the session. May I request Dr. Shukla to kindly join us onto the stage and present a memento to the moderator of the session. A huge round of applause, please. We have Dr. Shukla climbing onto the stage to present a memento to the moderator of the session. Ladies and gentlemen, presenting a memento to Mr. Srinivas Kasula. May I also request Dr. Shukla to kindly present a memento to Dr. Hans Friedmann. We also present a hamper to Dr. Hans. Now may I request all our panelists to kindly step forward for a group photograph. We would like to capture this moment. May I request Mr. Gaurav Mishra to kindly join us, the panelists, for a group photograph. Ladies and gentlemen, we are concluding the technical session now and moving into the next one. Once again, requesting all the panelists on the stage to kindly step forward for a group photograph, and we are being joined by Mr. Gaurav Mishra. Also onto the stage to capture this moment, we have our friends from Press and Media.